Alright everyone, we're going to be talking about parallel lines today. These notes are coming right from your notes packet. They should be right after the page that we did yesterday on angles. And so with parallel lines, we've already talked that parallel lines are two lines that don't intersect, or that do not, or that are the same line. Today we're going to be just talking about the situation when they don't intersect. So we have a couple of vocabulary terms that we want to get out of the way before we start. The first one being a transversal. So a transversal is just a line that cuts through, so that cuts or intersects two lines other than itself. And those lines are usually parallels. Today they're going to pretty much always be parallels, but there are other instances where that transversal is intersecting just two other lines. And so we have a picture of one right here below it. This line T that is kind of coming up on the angle is our transversal that is cutting two other lines. So we can write T is a transversal. Just like that. We also have another term called corresponding angles. So this is another pair of angles like the ones we were having yesterday. But for these ones, it is any pair of angle. So any pair of angles in similar positions. Similar positions relative to the transversal and each line. In other words, these are the angles that are sitting in the same corner when we look at our two intersection points. So we're going to look at an example of these here in a second. We're actually going to skip the next term. If you go down to the bottom of the page, there's an example down here. And so we're going to look at our corresponding angles. So our first pair of corresponding angles, if I look at angle 1, our corresponding angle is the one that's in the same position around the other intersection. So angle 1 is up here on the top where T intersects M. And it's kind of in that upper left position. In the upper left position on the bottom, we have angle 5. And so angle 1 and angle 5 are a pair of corresponding angles. So angle 1 and angle 5 are an example of corresponding angles. We also have some other pairs here. So we have angle 2 is on that top right of our intersection, and angle 6 down here is in the same position as well. So we have angle 2 and angle 6. So we can also put that over on the side. Angle 2 and angle 6 are also corresponding angles. We have two more pairs here. So we can look at angle 4 down below here. So angle 4 is on the bottom right. That matches up with our angle 8. I'm going to actually skip a spot here. I kind of went in the wrong order. Alright, so we have angle 4 and angle 8. And then our last pair that we have, I can find a color I don't have yet, is angle 3 here and angle 7. Those are on the bottom left. So I have angle 3 and angle 7. Alright, let's look at this list real quick. So of our list of corresponding angles, if you look down my first column here, I have my angles in order 1, 2, 3, 4. In this case, it happens that my other angles are also in order 5, 6, 7, and 8. That's not always going to be true. Okay, I can change how I labeled these different angles here, and I could not always be in order. So we always want to make sure we're just looking at the positions, not necessarily the numbers. Alright, so let's go ahead and go back up to the one that we skipped here. So we have another term or a postulate here. If you remember, the postulates are those things that we're taking to be true and that we don't have to prove. So our theorems we got to prove, our postulates we don't. Alright, so we have a postulate regarding corresponding angles. And it says that if we have two coplanar lines cut by a transversal, so that's kind of like our example down here. It's kind of off the screen right now. But we have two parallel lines and a transversal through it. And our postulate says that if two corresponding angles have the same measure, so we have two of those corresponding angles are congruent or are the same, then the lines are parallel. Just to go over one more time what that says. So if I have two of my corresponding angles, so down in my example, if angle 1 and angle 5 have the same measure, that would mean that my two lines that are being cut by my transversal, so here line M and line N, would be parallel. So those two lines are parallel. I can also go the other direction. If I know these two lines are parallel, so if I know line M is parallel to line N, then my two corresponding angles, or that pair of angles, are congruent, or they have the same measure. Those mean the same thing. So they're either congruent or they have the same measure. That's really just what congruent is. Alright, so that is it for our first page here. So we talked about parallel lines, and we now have a transversal and corresponding angles. So let's go ahead and flip over to the next page. This page here is going to get more into our parallel lines and what it really tells us when we have a parallel line cut by a transversal. So in this section here, we're now into the lesson 5.4 part of our day. So in lesson 5.4, we're talking about interior and exterior angles. And so in our picture here, I'm going to use some highlighters to help us out, but you can just kind of imagine this and label them the same way. Inside of our two lines, I have this area here that I'm shading in green. We're going to imagine that area in green to be a hallway. So kind of between our two lines here, we have a hallway. And so our lines inside of the hallway there are our angles, sorry, inside of the hallway are what we're going to refer to as interior angles. So that's our interior there in green. But I also have an exterior. So exterior kind of means the opposite of interior. So that is the pieces that are outside of my hallway. So I have one on bottom. I also have the same exterior on the top. Okay, so I have interior and exterior. Sorry, let me straighten this back out. Alright, so we have an exterior on the top and an exterior along the bottom. So I have interior, exterior angles now. And so our interior angles are all of our angles that are inside of our two lines, or are inside that hallway. So if I look here, I have angle 3, angle 4, angle 5, and angle 6 are all inside of that hallway. So I'm going to list those out here. I have angles 3, angle 4, angle 5, and angle 6. So over there on the side. Our exterior angles then are the other ones. So I have angle 1, angle 2, angle 7, and angle 8. Angle 1, angle 2, angle 7, and angle 8. Alright, and this is just naming these guys. We don't necessarily know anything about them yet. We're going to get to those in just a second. But right now, we just know that they're either interior angles or they're exterior angles. So let's go ahead and move down a little bit to our vocabulary section here. And we have these three letters AIA. So that AIA is actually an acronym for the term alternate interior angles. So go ahead and write that part out. So AIA is alternate interior angles. And so what that tells us is our interior angles, so we're inside of our hallway. And then the alternate piece means that we're on opposite sides of the transversal. So our definition here are alternate interior angles are angles on opposite sides of the transversal and on the interior of the parallel lines. I'm going to use that symbol there for parallel lines. I'm sorry that's kind of blurry there. See if I scooch it over if it gets any clearer. A little bit. Alright, so if we have alternate interior angles, let's go ahead and draw a little picture. So I am talking about my case where I have my parallel lines and I have a transversal cutting through them. I have that there. So my first pair of alternate interior angles, what I'm going to label here is angle 1 and angle 2. So those two angles are on opposite sides of my transversal, and they're on the interior of my parallel lines. So angle 1 and angle 2 are a pair of alternate interior angles. I also have another pair here. I'm going to label them with 2 lines. So angle 3 and angle 4, what I just drew there. So that's angle 3 and angle 4. Those are both both alternate interior angles. Give you a chance to write that down. Then we're going to go ahead and move on to our alternate exterior angles. That is our AEA. So AEA is alternate exterior angles. Alright, so with our alternate exterior angles, those are our angles that are again on opposite sides of the transversal. Opposite sides of the transversal. And in this case, they're on the exterior of the parallel, and I'm going to use that abbreviation or symbol, parallel lines. So I have alternate exterior angles on opposite sides of a transversal, which are on the exterior of my parallel lines. Again, I can draw a picture of this. I'm going to draw this a little differently than our parallel lines and our transversal we have been going with. Okay, so again, those are a pair of parallel lines. I have a transversal cutting through them. So in this case, I'm looking at the exterior angle, so I'm on the outside of my hallway. Right now my pen's kind of sitting inside the hallway there. So I want the angles on the outside of those parallel lines. And I have a pair on the top there and on the bottom over here. I'll call that angle 1 and this one angle 2. So again here I have angle 1 and angle 2 are a pair of alternate exterior angles. And I also have another pair, we'll call it angle 3 and angle 4 in those exterior angles. So angle 3 and angle 4. Give you another chance to get caught up on all of that writing. And we're going to go on to our next term down here. Alright, so our last term for this this section is what we're going to call the transitive property. So this transitive property is something that is true in all of mathematics, not just in geometry, not just in algebra, but in all mathematics. And so what it tells us is if we have two things that are equal and another set of two things that are equal, and one of those two things is shared, then the other two things are equal. Okay? I know that probably sounds really confusing without seeing it, so I'm going to go ahead and write the definition here and then kind of explain it again. So if A is equal to B, so I have the first two things are equal, and the second two things are equal, B and C, and I have one of them that is shared. So right now I have B is shared between both of these. Then I know, so then you know that A is also equal to C. So A is equal to C as well. So that is our definition of the transitive property. So the way we're going to think of this is we can think of our A is equal to B and our B is equal to C. So these B's here kind of group up. So our B's are both the same, so they kind of group up. And then my A can kind of jump across over here to my C. So my A is now equal to C. And this should make sense to us. If we have two things that are equal and they're both equal to another thing, then they should be equal to each other. Okay? So the reason that we need to talk about this property now is we're going to use it in this next question. So this next question asks us, why are alternate interior angles congruent and alternate exterior angles congruent? First of all, we haven't said yet that these are congruent, but it is a true fact that alternate interior angles and alternate exterior angles are congruent. But we do want to kind of show that. And so I'm going to actually show you one way to do this, and I'm going to show the interior angles are congruent. I believe it is a homework assignment for you to do the exterior angles. And so let's go ahead and pick a pair of interior angles. I'm going to look at angle 3 and angle 6 in this picture here. And so what I am trying to show is that angle 3 is congruent to angle 6. Yeah, I'm going to say that that is a true statement, and I just need to explain why. So I'm going to say those are true since, and I'm going to list out some justifications down here. We're going to get into some more justifying of things later this week and into early next week. Let's go ahead and look at doing this one. So my first thing here, I know that this angle, angle 3, is congruent to angle 2, right? We've talked about this part before. So these two are congruent, angle 3 and angle 2, because they're vertical angles. So I'm going to start with that. Angle 3 is congruent to angle 2. I'm going to say they are vertical angles. And they're vertical angles. That's my justification piece. My second part here, I know that this angle 2 and this angle 6 are also congruent. So I'm going to say angle 2 is congruent to angle 6. And I know those are congruent because they're in the same position relative to my line. That was those corresponding angles that we just talked about, that we said were congruent. So these are corresponding angles. So they are corresponding angles. Alright, and the last piece here. We're going to go ahead and say that angle 3 is congruent to angle 6. Let's go ahead and think about why at this point. Why can I actually say that now? Well, here I have these two angle 2's, right? So I have angle 3 is congruent to angle 2, and angle 2 is congruent to angle 6. Well, these two angle 2's here in the middle match up. Okay? Hopefully we're starting to think back to this transitive property right here. So I have my 2's match up, my angle 2's. And so my angle 3 then can jump over to my angle 6. And so what I can say here is that these two are congruent because they are, in fact, I'm sorry, that's not what I want. I don't want to say they are. They're not anything special. Okay? I'm going to say that they're congruent by the transitive property. By the transitive property. Alright, and that would finish this up. I have a complete list here now of a bunch of justifications that get me to the piece I was really starting with, that angle 3 is congruent to angle 6. And this will work for all of our interior angles. I could do it with angle 5 and angle 4 here as well. A very similar argument works for our exterior angles. You can use that vertical angle piece again to get to angle 3 and then down to angle 7. So that part I'm going to leave for you guys to do in a little bit, but we'll be talking more about how these justification works later on next week. But let's go ahead and look at some examples. So we have a practice page here. So up top, let's go ahead and start up here with number 1. So I'm told that in this picture, angle 1 is equal to 105 degrees. So that 105 degrees is angle 1. And I need to find all of my other angles, so find all of my missing angles. Let's go ahead and start with all of the angles that are the same as angle 1. Well, I know that angle 1 and angle 4 are vertical angles, so those two are congruent. So I can say that angle 4 is 105 degrees. I also know that angle 1 and angle 5 here are our corresponding angles. Those are in the same position. So those are also congruent. So angle 5 over here is 105 as well. And then our last angle that's going to be equal to those is our angle 8, Because angle 8 is vertical angles with angle 5. So now that I know angle 5 is 105, angle 8 must also be 105. So I think that is all of our angles that are going to be the same as angle 1. But I still have 4 angles that I need to find. So to find those angles, I'm going to use the fact that angle 1 and angle 2 here form a line. So angle 1 and angle 2 form a line. That would make these two linear pairs, which means they are supplementary and add up to 180. So I know that 105 plus my angle 2 here have to equal 180. So what I can do is I can do 180 minus the 105. It's going to tell me that that other angle must be 75 degrees. So my angle 2 here is 75 degrees. Now that I have that angle is 75, that's angle 2, I can also find angle 3, which is a vertical angle again. So this angle 3 is also angle 75. Angle 2 here is a corresponding angle down with angle 6, because those two are in the same position again. So angle 6 is also 75. And then our last one, angle 7 down here, is in the same position as angle 3. So those two are corresponding angles, and it is also a magical 75. Alright, so we should be seeing that we really only have 2 different measurements. We only have that 75 and a 105, because all my angles here are either congruent or they're supplementary, so they're always going to add up to 180. That's kind of an important fact that we can use here. Alright, let's go ahead and look at number 2 here. So number 2, we have a figure in which P and Q are parallel. So it already tells me I have parallel lines, and I have some missing angles here, but I'm told that angle 5 up here, the measure of angle 5, is equal to 5j minus 27, and the measure of angle 2 is 3j plus 5. So with those two, which are down here in the middle, I'm going to be able to work backwards and find j in order to find these 2 angles and then find all of the rest. So let's go ahead and start. I have angle 5 and angle 2 in here. These are in the positions that we would call alternate interior angles. They're on the inside and on opposite sides of my transversal. So these are alternate interior angles, which means that my 2 angles are congruent. So these 2 expressions they give us for our measurements of our angle, I can set those equal to each other. So I have 5j minus 27 is equal to 3j plus 5. Now I need to simply solve for j. So to do that, there's a couple different routes you could go. I'm going to subtract the 3j first. So 5j minus 3j is going to give me 2j. And I have the minus 27 is equal to 5. Now I need to go ahead and get that 27 to the other side, and to do that I add it to both sides. So I add 27 to both sides. Once I do that, it cancels here on the left, and 27 plus 5 is going to give me 32. So I have 2j is equal to 32. So right now I just need to get j by itself and divide by 2. So 32 divided by 2 just gives me 16 for j. Alright, I'm about halfway there to finding my first angle. So I found j. Now I can go ahead and find either angle 5 or angle 2 by subbing this j back into my expressions that they gave me at the top. So I'm going to go ahead and sub it back into angle 5. You could do it into angle 2, it really doesn't matter. So I have 5j minus 27 was my expression I was working with. So I'm going to take 5 and multiply it by 16 and subtract the 27. So I'm just plugging in my 16 for my j right here. At this point I can do 5 times 16, which I believe is 80. So I have 80 minus 27, which is equal to 53. So I know that angle 5 was the one I was working with, is equal to 53. So now I know angle 5 up here is 53. I'm going to go ahead and label that on my picture. So I know angle 5 is 53. So hopefully angle 1 is jumping out at us as one that I would know, because those are vertical angles. So angle 1 is also 53 degrees. I'm still looking for angle 3 and angle 4. Those ones are going to be a little bit harder to find. So I know that angle 5 and angle 2 are the same, right? We already said those are alternate interior angles. So angle 2 is also 53 degrees. It doesn't necessarily ask us for that piece. Okay? But down here, I have that angle 2 and angle 3 are forming this line here, this transversal. And so they must be supplementary and must add up to 180. So I can go ahead and subtract that. So I can do 180 minus 53. It's going to give me 127 for that angle 3. I can do a very similar thing to find angle 4 at the top. So angle 1 and angle 4 are also forming a line in our linear pair. So they must be supplementary and add up to 180. So again, I can subtract 53 from 180 and get 127. So again, you can see we really only have two numbers we're working with here, just the 53 and the 127. You're going to start to see in all of these parallel examples, excuse me, you're going to see that in all of these examples we're going to get to two numbers, and those numbers are going to be our answer for everything. Unless we get these weird expressions and we can change some stuff. But for the most part, we're going to get just those two. Alright, we have one more example here. I'm actually going to leave this one for you to do. And so this one here says to explain why angle 2 is equal to angle 7 without using the terms alternate exterior angles. And so we know that angle 2 and angle 7 are congruent because they are the alternate exterior angles. But I want you to kind of work through the same justification that we did on the last page, kind of on the bottom there. Let's check it out stuff. So I want you to work through a similar justification on this one and do it for the alternate exterior angles. Okay? And I'll be checking for that tomorrow, just like I'll be checking through all of your notes, and we're going to be counting these notes as a completion grade so that we know that everyone is following along with this video. Okay? So go ahead and fill that one out. Then you're going to go ahead and get started on your book assignment, which is on the backboard listed under Tuesday. So go ahead and get started on that. I will be back tomorrow and we can answer any questions that we still have from any of this.